Hello, welcome to Designs for the Edge with Microchip Technology. Designs for the Edge is our live stream series in which we talk about fast-growing markets and the technologies that are driving them forward. I'm your host, Eric Latfelter. We are live streaming, so please feel free to ask questions as we go through the discussion, and be sure to like, subscribe, and share as appropriate. Joining us today is Dave Schellenberger. Dave, welcome to the studio.
Thanks, Eric.
Dave, would you describe for our audience just what is your role here at Microchip Technology?
Sure. So I'm a marketing manager in our automotive products group. So our group supports our automotive clients, and we represent all of the different product lines within Microchip. And our main responsibility is to show our clients how Microchip can help them develop automotive embedded control systems that are reliable, robust, cost-effective, and help them get to market quickly with their designs.
Okay, so before we dive into the technology driving ADAS and AV, let's talk about those terms. So we see ADAS, AV, we hear AD being bandied around. What's the difference between all of these terms, and help us get situated in that landscape?
Okay, so ADAS stands for Advanced Driver Assistance Systems. And AV, AD, it's autonomous vehicle, autonomous driving, kind of same thing there.
Okay.
And people will interchange and conflate ADAS with AV, and there's a lot of similarities, but there are some distinct differences between them. If you think about the levels of autonomy, there's 6 levels of autonomy that are defined, level 0 to level 5. ADAS is more related to the lower levels, level 0 to 2, whereas AV is more the higher levels of autonomy, level 3 through 5. And if you think of a vehicle with a lot of ADAS features, it can drive down the road, it can navigate stop and go traffic, for example, but the driver has to be in control at all times. Whereas an autonomous vehicle, the driver doesn't need to intervene, except maybe in specific circumstances. And an autonomous vehicle, you may have heard the term data center on wheels.
Yes.
So that's a term that gets used a lot. Autonomous vehicle, it handles a massive amount of data. There's tons of data that's being communicated and distributed throughout the vehicle between sensors, cameras, to the zonal ECUs, and from the zonal ECUs to the central compute module. So it's just a ton of data, and so that's why it's commonly referred to a data center on wheels.
Right. Okay.
And an autonomous vehicle is always learning. With every mile it's driven, it's accumulating more data, interpreting that data, learning for future trips, or sharing that data with other vehicles as well. Another difference, ADAS is more of a modular approach. So you can add or remove features without significantly impacting the functionality of the vehicle.
Right.
A consumer can choose certain features when they select and purchase a vehicle. Whereas an autonomous vehicle, everything's interconnected, integrated. You can't remove a certain feature without a significant impact on the vehicle.
Okay, so let's talk about some examples of those ADAS features. So if I think about, we're just assisting the driver, like cruise control is assisting the driver, and that's been around for decades. Now, of course, the cruise control of the 70s is not the cruise control of today, but that's fairly modular.
Yeah, there's a lot of features like that people don't really maybe consider them as ADAS, but they truly are, and they've been around, like you said, for decades and decades.
Right.
But they've evolved over time. Cruise control has evolved to adaptive cruise control, lane keeping, lane departure, things like that. But and a level 0 vehicle basically has none of these features. A level 1 vehicle just has to have one feature that controls steering or acceleration, deceleration. Level 2 has to have 2 or more. And then you start getting into like level 3, where the entire vehicle can be autonomously controlled, autonomously driven.
All right, so in that space, what's happening in that market if we think about the companies that we all recognize as being in the vehicle space? What's going on in the market with them?
There's a lot of change going on. There's a lot of jockeying for position. There's a lot of companies that are increasing their investments in ADAS and AV, and there's others that are kind of pulling back, reevaluating. You know, it's not as easy as it looks.
Sure.
It didn't look easy to begin with. But you know, some of the more recent announcements, more recent developments, you know, Tesla has announced that they're going to increase their investment in robo-taxis. Mercedes just announced recently that they achieved the first certified level 3 autonomous vehicle for use in the United States.
Okay.
But then there's others that are kind of pulling back. Ford is divested from Argo AI, and they're bringing some of their development in-house. GM Cruise, you know, they've had a few hiccups. They've suspended some of their robo-taxi ride-hailing service, and they're focusing more on testing and collecting data. And then autonomous trucking, there's a lot going on there that most people aren't aware of. You know, Volvo recently announced that they have a production-worthy level 4 commercial vehicle,
Okay.
and they plan to deploy 20 of those by the end of this year. Waymo, they've kind of pulled back a little bit. They were developing self-driving commercial trucks as well, but they've kind of delayed some of their plans there.
Okay.
Too Simple is another one, a little more local here. They're headquartered in California, but they had operations in Tucson, and they've done several trips between Tucson and Phoenix with a self-driving 18-wheeler.
Okay.
So there's a lot going on.
Sounds like it. So there's some testing and some investing and some scaling back, but what would you say the overall trend is?
There's a lot of trends happening in this industry. You know, one of the big things is another term you may have heard. They talk about autonomous vehicles being referred to as software-defined vehicles.
Yes.
So software is a key component, a key characteristic. You know, the hardware, I wouldn't say it's becoming a commodity, but it's becoming commonized. So
Okay.
there's a lot of features that are kind of shared, and some of the things like AutoSAR have kind of made that more so, where the hardware isn't so much differentiated anymore, but the software is really a key component. It's a key competitive advantage for
Okay.
different companies. So that's
Now tell me,
what
I've
it
heard the
is.
term AutoSAR, but I can't say I know exactly what it is. Can you can you help me and those watching with what that is?
Yeah, so it's a standardized, it's an architecture that's standardized. So it kind of makes, in layman's terms, it makes the hardware easily swappable from
Okay.
one supplier to another. So you have
Okay.
different layers that everyone has to adhere to,
Right.
and so it makes it better for like the OEMs to be able to switch from one to the other. So.
Okay. Okay. So with all these, all these things going on, what would you say the biggest challenges are to somebody designing systems in this space?
Probably the biggest challenge when you're talking about autonomous vehicles is that a lot of the components and technologies that are needed weren't originally developed for automotive.
Okay.
And so they need to get these products qualified for automotive, qualified for the harsh, rugged environment that
Yep.
automotive's in. So when you think about products like PCIe switches,
Sure.
Ethernet, FPGAs, serializer, deserializers,
Yep.
things like that. A lot of those were developed for other industries.
Yep.
And Microchip was part of that as
Yeah.
well. So, you know, getting suppliers to qualify those devices for automotive is a challenge. Sometimes it's as simple as just doing some testing, but other times you need to make modifications, or you may need to develop, you know, new products from scratch
Yep.
that meet the certain characteristics or requirements for automotive. So
Yeah.
that's one big challenge. You know, as mentioned, you know, software-defined vehicle. One of the difficult things is you need capable, qualified software engineers.
Yes.
You know, that understand AI and things like that, and those are hard to come by. There's a lot of competition these days
Right.
for those guys, and so it's difficult for for companies to staff up and find the right people in those areas. And there's a lot of new specifications, a lot of new certifications that need to be had for functional safety, cybersecurity. So not only do they need the qualified people on their end, but they need to find suppliers that also understand those requirements and those certifications.
Right. So now last week we were talking about electric vehicles with Joe Thompson, and we were talking about vehicles in the past were marvels of mechanical engineering, and now they're marvels of not only electrical engineering but software engineering. And you just touched on that. It sounds like kind of ADAS is ground zero for the software coming together in the vehicle.
That's absolutely true. Yeah, software it's a very critical piece. It's a massive leap in terms of software requirements going from just a standard vehicle,
right,
where the driver does a lot of the input recognition and does all the decision making and things like that, to an autonomous vehicle where the vehicle has to interpret all the inputs, and you have inputs coming from all different sources, and then making decisions. And so it's very software intensive, and so it's, like I said, it's just a monumental leap.
Yeah, okay. So with all those challenges then, what are kind of the key technologies that Microchip is investing in that will help system designers get further down, get further forward in their design?
So we're investing in a lot of those things we talked about already. PCI, from the technology standpoint, PCIe switches, Ethernet, our bread and butter microcontrollers, microprocessors, FPGAs, SerDes. So we had a recent acquisition, a company called VSI out of Korea.
Right.
And they have SerDes products, serializer, deserializer, that'll be used for communicating between sensors and cameras to zonal ECUs or to the central compute. And then we're also investing in reference designs, proof of concept, demonstrators, and different collateral to help support customers, firmware, software, tools. I mean, you name it. We're in all aspects of.
Okay, so let's talk a little bit more about a couple of those different technology areas. First of all, in the networking space, what are the big pillars for networking going forward?
Yeah, so we have a three-pillar approach to the future of automotive networking. So it's Ethernet, PCIe, and ASA. ASA is Automotive SerDes Alliance.
Okay.
So Ethernet, it's an open standard. It's a scalable bandwidth. There's a wide range of speeds. You can go from 10 megabits per second up to 10 gigabits per second or more. And that's kind of the backbone for an autonomous vehicle. So that handles a lot of the communication between the central compute, the zonal ECUs, and then from there, maybe out to certain select peripherals.
Okay.
And then PCIe, that's more contained in the central compute module. So that's the interconnect between different SoCs, system on chips, within the central compute. So it's also an open standard. It's low latency, high speed protocol. And then ASA or SerDes, however you want to call it, again, that's also an open standard. It has, it's low power, low cost, and it has a lot of advantages over Ethernet and some of the other protocols that are being used for camera and sensor connectivity, like FTP link and some of the others. But it's, as I mentioned, lower cost and achieve higher speeds and go up to 16 gigabits per second. It's open, with the Alliance, there's approximately 150 members in that Alliance, 10 OEMs, and it's growing. So it's open, and there's a lot of people contributing to developing the standards and things like that. So a lot of advantages for the
Okay, so you mentioned latency with PCIe, so I just want to dive into that a little bit, right? And I think of an old CAN controller or something that's sending a signal like when I push a button to raise the window or something like that. Not a lot of data going through there and not really speed critical, can just react whenever it is. But a lot of what is happening now is the amount of data is orders of magnitude bigger, and the requirements for low latency are critical because it's safety related, right?
Not only is it safety related, but decisions need to be made rapidly.
Immediately. Okay.
Immediately, yeah.
Yeah.
And so yeah, latency. That's a death, to an autonomous vehicle.
Okay,
If
yeah.
it can't react
Right.
in a timely manner. And as you said, there's tons of data that's being collected and being synthesized. You have data coming from cameras. You need to match that up with data that you're collecting from LiDAR or
Yep.
from LiDAR sensor or from
Yep.
radar.
Yep.
And so if there's latency effects, you could interpret these things incorrectly.
Sure.
You could maybe
Make a bad decision.
exactly make bad decisions.
Or not make one.
Yeah.
At a time. Okay. Interesting. All right. So the other kind of technology area I wanted to jump back to a little bit is security. How important is that? How pervasive is that?
It's incredibly important when you talk about an autonomous vehicle, because there's so much in terms of interconnectivity. So
Yep.
within the vehicle, as we mentioned, connecting the different compute modules, and connecting with the sensors, and connecting with the driver, things like that. And then outside of the vehicle, so you have vehicle-to-vehicle connectivity,
Sure.
vehicle to infrastructure, vehicle to home,
Yeah.
vehicle to cloud.
Yeah.
So, and all of that needs to be secure. So it's the utmost importance when you're talking about an autonomous vehicle.
Right. And now there's hardware and software solutions for a lot of the challenges there, correct?
Mhm. Yeah, and Microchip's spent a lot of resources, a lot of time, a lot of effort in developing those. We have a suite of products that provide hardware security, and then of course we have to develop the firmware that goes along with it, provisioning, things like that. So and then all the collateral that supports that, and all that. So it's a big area of
Yep.
investment for us.
Okay.
Area of focus.
Okay, so, and the last thing I wanted to circle back around to was, and you mentioned this before, functional safety.
Functional
So let's
safety.
talk about that a little bit more. What does that mean in the automotive environment?
Well, it's critical in automotive environment, but it's even more so when you talk about an autonomous vehicle, because in a standard vehicle, the human driver makes all the decisions, interprets all the inputs and all that, so they can make adjustments and things like that. But when you're relying on the vehicle to make all those decisions, the safety is very critical.
Yeah.
And so, it becomes even more so, because you need to have a lot of redundancy in case there's single point failures and
Okay.
things like that. And so, if something does go wrong, the vehicle needs to be able to react and interpret that.
Okay.
And so
Okay.
it just becomes even more important. when
And
we're
there's
talking
pretty
about
rigorous
autonomy.
methodology to product development in that
Yeah,
space.
and again, that's another area where we're focused on and investing in, developing products that are functionally safe, that meet a lot of the requirements that are defined by ISO 26262, which is the functional safety standard for automotive, collateral that supports that as well, diagnostic code, FMEAs that help determine the safety sort of aspects of a product. How well, when errors occur, how well are you able to diagnose them and correct them?
Yep.
Things like that. So we spend a lot of effort in doing that, so we can help our clients develop functional safe
Yep.
products, applications that meet the highest level.
Yeah.
highest
Wow, this stuff is amazingly complex. So how do we, how do we help customers in this space implement their designs? What's, wrap it up with the software and the tools and the hardware. How do we bring this together?
Yeah, so we started these megatrends initiatives a few years back, and one of the key things was to put all of this information, all of our expertise together for customers to kind of make it a one-stop shop
Sure.
for them. So.
Okay.
We developed reference designs, as I mentioned, demonstrators, all the collateral, block diagrams. We put it all together for customers, and we we model, define, and test the interoperability of our products so that they can get to market quickly with a solution, and provide all the technical support to them. Again, all the collateral and things like that. So we try to make it readily available, easy to use, and we're there standing by them to help them get through that, and because we want them to be successful. Because if they're successful, we're successful.
Great, great. All right, David, let's pause there. Thank you so much for sharing your experience and your expertise in that topic. Let me check our social media feeds and to see if we have questions from our audience today. So, first question is, who would be the leading suppliers of software for automotive applications?
The leading suppliers of software. Well, it depends on which aspect you're talking about, because a lot of the, traditionally it's been a lot of tier one suppliers that would do the software development. The OEMs are taking more control of that, a harder approach to that, because number one, as I mentioned before, that's a key differentiator. That's a key competitive advantage. And so the OEMs want to keep that close to us. So they are bringing a lot of the software expertise in-house, and they're hiring a lot. So, in terms of like the application aspect of it, it's the OEMs that are leading. I can't really say comparing between the different OEMs who's doing better or what, but they're taking a lead on. But then the semiconductor suppliers also have to provide certain parts of that, software libraries, MCALs for AutoSAR, for example. And then there's third-party companies like Electrobit, Vector that also provide software. And so those are some of the key ones. But yeah, everyone has their hand in that software somewhere.
Okay. All right. Second question: what are some of the main trends in ADAS sensing?
ADAS sense. That's a good question. There's a lot going on there because sensing is pretty complex. There's four main areas for sensing in an autonomous vehicle. There's LiDAR sensors, light detection and ranging, radar, ultrasonic, and then cameras. If you think of those as sensors. And so getting all those to play together is a big challenge. And there's a lot of them in an autonomous vehicle. And so, the trends are, how do you make that, how do you make those work together in the most efficient, economical way, make it robust, and make sure, like you said earlier, you got to make the right decision. So all that data needs to be interpreted correctly. So the automotive customers are trying to find the right mix of those sensing technologies. And then, it all depends too on which type of vehicle you're talking about. So you talk about a long haul truck that's going down the interstate at 65, 70 miles an hour. Their requirements for sensing are going to be completely different from a robo-taxi that's maybe sticking to city streets and traveling at lower speeds and has to recognize more, a semi-truck doesn't really expect pedestrians to be walking across the interstate, hopefully not. Whereas, a robo-taxi, that's going to be more
crosswalks and sidewalks.
Kids kicking a ball out in the street, things like that. So a lot of that depends on the type of application. And then, things like, a truck, it can accommodate, more sensors, so size and weight aren't really as critical as it would be for a passenger vehicle, because those have minimal impact and cost as well, because one of the key things about having a self-driving commercial vehicle is you can eliminate the driver, so you don't have to pay a driver, so you can amortize the costs for sensing a little better on those types of vehicles.
Interesting. Okay. So you've got a mix of sensors, but the mix depends on the vehicle and the use case as well. Interesting. Okay. A couple more here. So what is the future of ASA? So you mentioned ASA in the networking space.
Yeah, ASA, Automotive SerDes Alliance. So as I mentioned, there's about 150 members today, 10 OEMs that are involved throughout the world. Probably the one that's leading the charge there is BMW. They've announced that they're going to have this technology in their vehicles for LiDAR in 2027 and for cameras in 2029. But there's other OEMs too that are evaluating or developing with that technology today. So we expect it to grow. I mean, with that many members, with that many people involved, and with all the advantages that I had mentioned earlier, it's just going to take off. You know, like I said, we think it's one of the 3 pillars. So it's going to continue to grow and to develop. And with it being open, you know, more people are going to get more. Suppliers are going to get involved with that and be contributing to that. So we think that's a big growth area.
Great. All right. Looks like we have 2 more. Jianchun wants to know if there are suggested systems on chip to run automotive operating systems.
Yeah. So there's some of the main players for SoCs in autonomous vehicles are NVIDIA, Qualcomm, Intel, Samsung. So they, you know, we work closely with them. You know, we don't make the SoCs ourselves. That's a little higher level than what we traditionally offer, but we do support. You know, so like PCIe for the interconnectivity, power management, because when you start talking about a lot of SoCs and a central compute, you're gonna have a lot of different voltage rails and things like that. So PMICs, power management ICs, you know, we provide those. Timing, our timing devices, you know, that's critical in central compute and also on the sensing side of things. So those are some of the ways that we can support. Security also, as we talked about before, you know, we have a suite of products, our trust anchor devices, which are standalone security devices that can be added to SoCs, for example.
Yeah, all right. Last one that I see here is Microchip certified to ISO 21434.
Yes, we are. So ISO 21434, that's a new, relatively new cybersecurity standard, road vehicles.
Back to the security.
Yeah. So it's the road vehicle security standard. You know, it was created to give certain guidelines for developing in the cybersecurity arena. So, you know, it encompasses everything from IC design development to firmware, software, things like that. And so Microchip has been certified by a third party, UL Solutions, to that standard.
All right, excellent. I see no additional audience questions, so we'll wrap it up there. David, again, thank you for joining us and sharing your expertise with our audience. Thank you to everybody who is viewing for taking some time out of your day. Please visit us at microchip.com/designs for the edge. You can see our remaining episodes for this season. You can sign up for notifications. Please remember to like and share the episode. Thank you so much, and we'll see you next time.